Deep beneath the ground, a machine waits in the dark. Years pass. The detector remains sealed off from the noise of the surface world, watching for an event so rare that it might happen only once among countless ordinary particles passing through it. This is not a rough experiment. It is one of the most sensitive searches ever built. The assumption seems simple. If the signal is real, a detector good enough should eventually see it. So the search improves. The instruments become more sophisticated. The waiting continues. Then XENON1T reaches a strange destination. Nothing appears. No confirmed dark matter signal emerges from years of observation. The detector keeps watching. The expected interaction never arrives. That changes the problem. Dark matter is no longer difficult simply because it cannot be seen. Scientists have now built machines specifically designed to find it, and the result is still silence. The missing signal starts creating pressure of its own. The search begins looking less like a technical challenge and more like a prediction that refuses to cooperate. And as the detectors keep getting better, one question becomes harder to ignore. Why does the signal keep failing to appear? The silence does not stop the search. New detectors come online. They reach deeper than the machines before them. They become more sensitive, more precise, more capable of catching interactions that earlier experiments might have missed. At first, that seems encouraging. If the signal has stayed hidden, then a better detector should finally reach it. But the pattern begins repeating. The searches expand. The detections do not. Instead, something else starts disappearing. Some of the answers people expected to find? With each new generation of experiments, regions of the expected search space begin falling away. Ideas that once looked promising survive the design phase, survive the calculations, survive years of anticipation, then quietly fail when the data arrives. The map does not stay the same. Large sections are crossed out. Ideas that once survived years of calculations suddenly stop surviving contact with data. Places where dark matter was expected to be become places where it apparently is not. That changes the meaning of every non-detection. The search is no longer waiting for confirmation. It is actively ruling possibilities out. What once felt like waiting starts looking more like elimination. The search area keeps shrinking. The predictions keep losing territory. And yet, the detectors continue pushing forward, as though something important still remains somewhere beyond the regions that have already disappeared. The shrinking search area creates an unexpected feeling: confidence. Not because dark matter has been found, but because the search is finally approaching the place many researchers expected it to be all along. The detectors keep improving. Their reach extends into territory that earlier experiments could not touch. What once seemed distant now begins moving within range. For years, one possibility has stood out from the crowd: WIMPs. Among the many ideas proposed, these particles have long occupied some of the most promising ground. As the technology advances, scientists become capable of testing the exact region where many expected the answer to be waiting. The destination finally feels within reach. The search is no longer wandering through a vast unknown landscape. It is closing in on a destination that decades of theoretical expectations have repeatedly pointed toward. That changes the mood. The missing signal no longer feels impossibly far away. It feels close. The remaining distance starts looking technical rather than fundamental. The problem appears less like finding dark matter and more like reaching it. One more improvement. One more generation of detectors. One more step into the predicted target. For the first time, the search appears close to resolution. The machines are finally reaching the territory where many physicists expect dark matter to reveal itself. The answer seems less like a distant possibility and more like something waiting just beyond the next technological horizon. The moment finally arrives. The detectors reach the territory they were built to reach. Years of engineering, years of upgrades, years of waiting all point toward the same destination. Xenon 1T and the experiments that follow achieve levels of sensitivity that earlier generations could only aim for. The search pushes directly into the parameter space where many researchers expected dark matter to be hiding. The assumption is still intact. If the prediction is correct, the signal should appear now. The machines keep running. The data keeps accumulating. The detectors keep watching. The expected signal never appears. Not after months. Not after years. Not after reaching the place it was supposed to be. Not because the instruments fail. Not because the search stopped short. The expected destination is reached. The discovery is not. That distinction changes everything. For decades, the weakness seemed obvious. The detectors simply needed to become better, more sensitive, more capable. Now that improvement has happened, the detectors are probing exactly where many expected the answer to be, yet the anticipated signal remains absent. The pressure shifts. Attention begins moving away from the machines and back toward the expectations that guided them. A prediction that helped shape generations of experiments no longer gains strength from each technological advance. Instead, every successful search that finds nothing places that prediction under greater strain. The technology appears to be doing its job. The expected result is the part refusing to cooperate. And that creates a far more uncomfortable possibility. The search may be working correctly while some of the assumptions that guided 40 years of searching are incomplete or wrong. But if the detectors succeeded and the prediction failed, what exactly has all that searching accomplished? The easiest conclusion is that nothing was found. But that is not what happened. The detectors ran. The searches expanded. The expected signal failed to appear. Yet every time that happened, another possibility was removed from the map. The machines were doing exactly what they were built to do. Not finding the expected particle was still a result. A measurement had been made. Over decades, experiments systematically tested and eliminated many of the possibilities that once seemed most likely. The empty spaces left behind were not gaps in knowledge. They were knowledge. That changes the meaning of still no signal. The silence was never evidence that the detectors failed. It became evidence that some of the expectations guiding the search were too narrow. The technology advanced, the predictions lost ground, and the search forced a difficult adjustment. The evidence pointing toward dark matter never disappeared. The need to explain that evidence remained. What changed was confidence in where the answer would be found. 40 years of searching did not end with the discovery. They ended with fewer assumptions. The search did not fail. It succeeded in eliminating many of the answers scientists once expected to be right. It removed certainty. The evidence for dark matter remained. The expected particle did not. And that left modern physics with a harder task than before, explaining why the universe continues to show overwhelming evidence for dark matter while refusing to reveal the particle many expected to find.